So today let's see how we can use all the things that we have learned about Matplotlib to explore an open source dataset. So, so this is the dataset that we are going to explore today. So this is for the student performance on two subjects, mathematics and Portuguese language. And it has 30 features with 649 instances. And it's a relatively small dataset, but a good one for our demonstration. So let's just go ahead and download this from here. I have already downloaded it and I extracted the files from the zip over here. So we get two CSV files, student POR and student MAT for the maths and the Portuguese stats. So for now, let us use only the maths one for the demonstration purposes. And also for this tutorial, we are going to use a Jupyter notebook instead of a Python script, since it's much easier to run the code cell by cell and see the output while we explore the data. So let's quickly go ahead and import the pandas and the matplotlib library and import the dataset that we have downloaded. So to import a CSV file into pandas, we can use its read CSV method and store it in a variable. So we can do something like, and we give the path of the CSV file. So it's in the data folder. Okay, so now as we have imported the data into our data folder, what if we want to take a look at our data to see how it looks, the different columns and the values, and just get a feel of it? So there is a function called head for the pandas data frames, which we can use to look at the first 5 rows of a data set and a few of the columns. So let's go ahead and use that. Okay, so as we can see over here, there is some issue in reading the data. Now, can you guess what happened? Now, just looking at the data over here, I can see that there are a lot of semicolons in the data. So maybe the CSV file that we are trying to read is not actually comma separated, but instead semicolon separated. So let's just try to open it in Excel as well and look at it. Okay, so as you can see, we guessed it right. It is not a semicolon. It is a semicolon separated file and not a comma separated file. So what do you do in such a case? So it's not a big issue if the separator is not a comma, but we just have to specify it that what the separator is. So there is a parameter called sep that we can pass, and we have to pass it the separator that is used in the file. So it could be anything, whether a semicolon or a pipe, but we have to specifically specify it because if we don't, then it defaults to a comma. So after reading the data again, let us try to run this again and see. Now we are able to see what the data looks like. So there is the school, the sex, the age, the address for each of the students, and there are a lot of the features over here. So in this, as you can see, we can see the first 5 rows and some of the columns over here. There's a few dot dot dot. So this dot 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 means that there are more columns, but the columns have been truncated for visual representation. So what we can do instead, if you wanted to look at all the columns and also all the data types that are there, we can call the info method on this. So with the info method, we can see what all the columns there are, the data type, and the number of non-null values over here. So as we can see, mainly in our data frame, we have two data types, integer and object. So an object data type in pandas can actually hold any Python object. But since we have read the data from a CSV file, this is just most probably a string. So on this website itself, if we go down, we can see they have given a description of what the features are and whether they are categorical and the values that they can take. So there is also a more comprehensive list over here for all the features that we have. So in this data set, the dataset I actually used to see if your machine learning models can predict the G3, the final grade of the students using all these attributes. So let's dive back into here and let's see what more we can explore in our dataset. So first of all, let's just by looking at these values, we are able to tell that maybe the M job, the mother's job, and the father's job values are categorical in nature. So when we have values like this, we might want to see their distribution or what are the different categories in that column. So there is a function called value counts that can be used on a particular column to do exactly that. So in Pandas, to select a particular column, we just uh, give its name inside square brackets. So let's just choose the M job. Okay, so now here, as we can see, there are 5 different categories: others, services, at home, teacher, or health. And most of them are in either in others or in services. So using value counts, you can get a good look at how the categorical variables, the values that the categorical variables have, and the distribution as well. So this was for a categorical variable. But for a numerical variable, you might want to look at some other things. For example, so we have an age over here. So we might want to look at what the average age in the data set is, what is the mod, median, etc. So for that, either you can use the average or the mean functions on individual columns, or we can just use a simple method that we have in Pandas called describe. So what describe does is it will tell you all about the numerical columns. So over here, age, this is the count, the just the number of rows. What is the mean age? What is the standard deviation? What is the minimum age, the maximum age, and the 25th, 50th, and the 75th percentile. So what the 25th percentile or the 50th percentile mean is that, for example, since the 50th percentile is 17, 50% of the 50% of the students in this data set have a age that is less than 17, and 75% of those have a age less than 18. And similarly, we get a good look at all the other numerical variables as well. So this does give us a good idea of the distribution of the data. But since we were learning about Matplotlib for such a long time, why not use the skills we have gained till now and make some graphs to get an even better understanding instead of just looking at these numbers? So what we can do is just plot a histogram for all the numerical features in the data, and then we can see the distribution of those numbers visually. So how you can do that is just use the hist method, as we have seen in the past videos. So you can use the hist method even on complete pandas data frame. Also, one more thing, whenever you're running matplotlib code in a Jupyter notebook or a similar environment, we have to run a magic command called matplotlib inline. So what that does is it shows the graphs in the notebook itself instead of showing it in a separate window, which is much more convenient. So to run a magic command, you just use the percentage sign. So this won't produce any output, but uh, since we have run this, now all the graphs will not show in a separate window. So now let's go ahead and make histograms for our data and see the distribution visually. So as if you can recall from the previous videos, we just have to use the hist method to make a histogram. But instead of doing it for every single column, we can just do it directly on a data frame and we'll get the histogram for all the individual columns. So here I'm just passing 2 arguments. Bins is just the size of each bin for the histogram, and the fig size is the size of the figure. So I'm just making it small so that all of them can fit. Okay, so the argument does not contain an underscore. It's just fixed size. So as you can see here, we have, let's actually make them a little wider instead of taller. Yeah, much better. So as we can see, uh, the age is distributed in a way that there are a lot of young kids, then there are some middle-aged kids, but not very much older kids. In the father education and mother education as well, there is uh, almost evenly distribution, but we can see there are not many people with one. And as over here, as we can see it, you can see it all for the all the columns. Even the scores have a kind of bell-shaped distribution with most of the students in the middle around the average, and it tapers down when it goes to either of the sides. Okay, so now let's do something more interesting. Let us see the correlations between each of the columns. What does a correlation mean? So correlation means when we are comparing two columns, if the value of one column increases and that also corresponds to a similar increase in a second column, that means that two columns have a positive correlation, and otherwise a negative one. So even a negative correlation or a positive correlation means that the feature will help us determine what the uh, our target variable is. And zero correlation means that they do not have any kind of relation with each other. So for that, instead of Matplotlib, we'll also learn about a new library called Seaborn. So Seaborn is also a library that's used for making plots, but it also has some more functionalities. So we can import that as such. You might also want to install this library with pip install Seaborn if you haven't already. You can also do that inside the Jupyter notebook as well using the explanation command, exclamation mark. So exclamation and then pip. It won't install it for me as it's already installed, but this is one way to install the library. I'll also add all the libraries that need to be installed in the description as well. So now to get uh, the correlations, first the thing that we need is we can only calculate correlations between numerical columns. So for that we can use the include dtype function on a pandas data frame to only include columns with a certain data type. So then we'll give it the include parameter. So this way we are only getting the data that is numeric. Now that we have the numeric data, we can just calculate the correlations using the inbuilt method in the pandas data frame called CORR, C-O-R-R. So now we have the correlations. Let's just make it. Let's just pass this to the Seaborn library. So SNS dot heat map. So this CMap argument over here does what is that it defines the color scheme used in the heat map. So cool warm is a general good red and blue color scheme to use. Okay, so my bad, the function is not called include dtype, it's called select dtypes. So over here now, as we can see, we get a diagonal over here which is completely red with 100% correlation, because that is just the correlation of that variable with itself. So obviously it has 100% correlation. Otherwise, there is a very strong negative, not very strong, but some negative correlation between failures and the grades, and somewhat somewhat good correlation between WALC and DALC. So let's see what those variables are. Okay, so they are for weekly alcohol consumption or daily alcohol consumption. So yeah, that makes sense. Person who is people who drink weekly more are also the ones who might maybe drink more on a daily basis. And there is also very high correlation over here between the grades. So that is actually because the G3 is calculated using G1 and G2. So G1 and G not only G1 and G2, but G1 and G2 are also a factor in calculation of G3. So that is why it has a good correlation. And it's just like saying that students who score good marks in midterm exams also score good in end term exams. So even though there is very strong correlation here, that's not very helpful, but we can see that easily using this heat map. But as we can see over here, the diagram does not look that good, and there is also a lot of redundant data in here, since this cell over here is exactly the same as this cell over here. So if you can see, it is just a mirror image of itself among the diagonal. So what we can do is we can use some more parameters to the SNS heat map function to make this a lot more uh, visually appealing, let us say. And also there is a function a feature called mask. So applying a mask means that we can also hide some of the cells in here, so as not to see the redundant data. And that's also a good opportunity as for us to also learn about a new library called NumPy. So we'll also import that. So now NumPy has a function called tryu mask equals to tryu. So it just means a upper triangular matrix. So it makes a matrix of a shape which has values 1 in the upper triangular part. So it will have values for 1 for all these columns and 0 for all these. And we just have to give it a shape. So the shape is the shape of the correlations matrix. So what we can do is just use another method from the NumPy library called once like. So now this gives us a upper triangular matrix of ones, and let's pass this as a mask in here. So now as we can see, the upper triangular part along with the diagonal is gone, which was anyways not very helpful information. And now instead of going too deep in the visual representation, but just for the sake of demonstration, let's just also add some more arguments over here. So what we did over here is now we have the mask and correlations as well. ANNOT is for annotations. When we set it to true, we also get to see the numbers inside of the cells. Then we have a cool map, the color type, the Vmin and the Vmax are the minimum and the maximum value that should be used. So it should go from 1 to -1. Then we are making it a square. The line width is 0.5, so it is a lot more clearer. So now when we run this, we can see it's a lot more better, but the figure size is not very small still. So to increase the figure size, we can just change the figure size. So now as we can see over here, it is much better to look at, even with the numbers, and now it goes from -2 to +1. So now as we can see, it's still the same information. We have a lot of correlation in the grades, then bit of a negative correlation between the grades and failures. So what exactly are failures? So failures is the number of past classes failed. Okay. Okay, so this was for the correlations. Now, what else would we want to explore in a data set before starting with training our models and looking at the results. So looking at the features and how they relate with each other is good, but let's also look at the distribution of the actual target variable, the G3. So even though we saw it over here in this histogram that it's kind of a bell shape, we can make a much more beautiful, we can make a much better histogram specifically for G3 just to see how it looks. So we still use the histplot function, but this time instead of matplotlib, let's use SNS and give it the bins of 20. And what over here, what we are doing KDE true is KD is the kernel density estimate function. So instead of, so what this does is it draws a smooth line as well on the graph. This line over here, as you can see, this is the KDE line. So this is just the smoothened out probability distribution for this variable. So now, as we can see, the graph looks exactly the same, but it's much better to look at. So as we can see, the graph still looks the same as it did here, but it's much better to look at and also much more clearer. Okay, so let's move ahead. Let's also go and explore the data a bit more. So now over here we saw the correlations of all the features with all the other features. But what if we only want to see the ones which are the most correlated with the target variable, since that's what we are finally want to predict, right? So which features are the most correlated with this? So what we can do for that is, so what we can do is that we get the correlations only for the G3 variable with all the other variables, then sort it in a descending manner and then drop the correlation with the G3 itself as it is anyways going to be 100%. And then we'll get the top 5 features and then make us 2 by 3 subplot that using the plt.subplots method that we learned in a previous video. And then what we can do is that just plot that specific feature with G3 using a scatter plot. And we'll also all plot a reg plot. So what a reg plot does is it creates a regression line on the scatter plot, and a regression line is just a line that best fits the data. So you'll understand more when we see it. So as we can see over here, we know that G2 and G3 are the most correlated features, and then G3 is also very correlated with G1. But then the next three are mother's education, father's education, and the study time. And this red line that we can see over here is the regression line. So this line is the line that best fits the scatter plot. So if this line has a very good positive slope, it means it has a positive correlation. If it has a negative slope, it means a negative correlation. But as we can see, these lines are mostly flat. So there is some correlation, but not very strong. So this we can do using the reg plot. So this is also a inbuilt method in the Seaborn library. So now let's move ahead. So this all was for numerical features, right? But what if there is not very good correlation with numerical features for the target variable, as we can see over here? There is some correlation, but not that much. So maybe it has a better correlation or a better relation with the categorical features. How we can see that? So for that, we can use box plots. So box plots are just a way to see the distribution of those variables. And what we'll do, we'll draw two box plots side by side, one for the G3, the target variable, the final term grade, and some of the categorical variables. We'll only select 9 for now for demonstration. And let's see how they do. Okay, so over here, as we can see, the G3 by school. So this is the distribution of the grade for GP school, and this one is for the MS school. Then this is by address, by family size. So greater than 3, less than 3. So there are a lot of variation in here. Over here, as we can see, by if we see G3 by father's job, we can clearly see if the father is a teacher, there is a noticeable increase in the grades. which somewhat makes sense. And one more thing. So as over here we can see there is a lot more spread over here in the P status, which is the parental status. Let's see what exactly that is. So where is P status? Uh, okay, so P status. So that is whether their parents are living together or have they uh, broken apart. So over here we can see that we might conclude that parents who live together have a general better performance for their students and also much more spread out. Like the children whose parents are apart have a lower minimum, a higher minimum than the parents who are living together. But there might also be some other underlying reason for that. Maybe there is just a lot more students whose parents are living together than there are whose parents are apart. So how we can check that? As we just explored, we can use the value counts function. And as we guessed, there are a lot more students whose parents are living together than there are whose parents are living apart. So that's the reason for this higher spread. So even though we can use box plots to get a general idea of the relation or the distribution of the target variable across different values of a category, it's always a good idea to explore each one in depth if you seem it is significant enough. So this was for the box plots. Let's explore the data set even more. So one more thing that we can do is, like, we saw that we made a KDE graph, the kernel density estimation for the target variable, and also we made some scatter plots for all the different variables. But there is also another plot called a pair plot in Seaborn. So what that does is we can use some variables that we think are important, and then we make and then we make both scatter plots and their kernel density estimation, the probability distribution for those variables in a single chart. So this has the KDE plot on the diagonal and the scatter plots in each of the cells. So this one is for study time and G2. So over here also we can see all the grades are correlated with each other and not too much correlation among other variables. But the pair plot is also a good plot to see relationships between the variables. So this was for exploring the data set. Let's just do one more fun thing. So what we can do is uh, not train the model right now, but just for the demonstration, what we can do is we'll just see if we trained a simple model like a random forest regressor to predict the output variable, what features it thinks would be the most important. So what we'll do is we'll first import the random forest regressor from Sklearn. So Sklearn is also a library that has a lot of good features for machine learning. So what a random forest regressor is, will not go into depth for now. That's a topic for another video. But let's just use this and see the feature importance. So I won't dive too deep into this code, but over here also what we are doing is just getting the numeric data. We are dropping target, the target variable from the training data, and we are using it separately as the labels. Then we are using a random forest regressor, fitting the data into it and seeing what features are the most important according to that model. So this is the bar plot for the feature importance. And as we can guess, G2 is very important for predicting G3, but that's not very useful in a real world scenario, as it's just like saying students who get a lot of marks do get a lot of marks in other exams as well. So we won't really even be having the marks of students if we want to just use the other features like their ages, health, the family relations and all to predict how well a student does in school. But since G2 is also used in G3's calculation, it has a very good correlation with it. This is the most important feature, and according to this model, the other important features were the absences, the age, the health, the family relationship, and G1, father's education, study time, etc. So this is all for today. In a future video, let's explore how we can train a simple machine learning model to actually predict what the target variable is, so that we can use all the knowledge that we gained from this data exploration on to choosing which model we can use. For example, when you're exploring the data and you see that a lot of high correlation with numerical features for the target attribute, we might want to use a linear regression model or a multiple regression model. And maybe if there is no clear relation with the numerical features or there is no proper correlation or such, we might want to use other models like gradient boosting or a random forest maybe. So let's see that in the next video. So be sure to subscribe to our channel if you haven't already, so you don't miss out on any future content.